Hello, everyone, and welcome to today's Explainer. We're about to jump right into an incredibly fun journey breaking down the foundational building blocks of the C programming language. Whether you're aiming to write an entire operating system, program tiny microcontrollers, or you just want to master literally one of the most influential languages in computing history, well, you're in exactly the right place. Here's our roadmap for the course today. We'll start with the foundation of modern computing, move into the anatomy of C, cover data variables and constants, explore operators and logic, touch on input and output, and finally wrap up with control structures. Let's get right to it.
Part 1. The foundation of modern computing. Why does C actually matter today?
Okay, so here's a pretty wild fact to kick things off. This language was developed way back in 1972 by Dennis M. Ritchie at Bell Labs. Yet it is still the absolute bedrock of modern computing. The Unix operating system was famously rewritten entirely in C. And today, huge chunks of Windows, Mac, and Linux all rely heavily on it. It is, quite literally, everywhere.
And really, that brings us to what programming actually is at its core. I love this quote because it hits the nail on the head. Programming is essentially just handing a computer a highly detailed, step-by-step recipe that it has to follow. You see, computers don't guess. They execute exactly what you tell them to, no more, no less. Your real job is translating your messy human ideas into pristine machine-readable logic.
Moving on to Section 2, the anatomy of C, and why it's known as a middle-level language. C is incredibly special because of exactly where it sits in the programming ecosystem. On one extreme, you have low-level languages, like machine and assembly code. They are lightning fast, sure, but they're incredibly tedious and difficult for humans to read. On the other extreme, high-level languages like Python are super easy to read, but they're highly abstract. C? Well, C perfectly bridges that gap. It offers the readable syntax of a high-level language while still handing you the direct, bare-metal hardware control of a low-level one. It's the best of both worlds.
So how does the code you type actually become a running program? Let's unpack that black box, because it's actually a 6-stage pipeline. First, you edit your source code. Then the preprocessor steps in to handle directives. Next, the compiler translates your code into assembly language, and the assembler turns that into raw binary machine code. After that, the linker connects it with any necessary outside libraries, and finally, the loader executes it. It's a highly precise, multi-step journey.
But listen up, because we are officially entering our first danger zone. C is notoriously strict. It's completely case-sensitive, you can't use built-in keywords for your own names, and you absolutely must include a main function. But the biggest trap for beginners, for sure, it's forgetting a single semicolon. In C, every single statement has to end with a semicolon, or your program will instantly crash during the compile phase. It's totally unforgiving.
All right, Section 3, Data Variables and Constants. Basically how we store information.
You can kind of think of data types like labeled storage boxes sitting on a shelf. An int box is typically 4 bytes big and holds whole numbers, and it uses the format specifier %d. A float holds your decimals, while a double gives you double the precision in a larger 8-byte box. And a char? That's just a tiny 1-byte box for a single character. Using the exact right format specifier is absolutely crucial when you want to look inside these boxes later. Now, we actually have two distinct types of these boxes: variables and constants. Variables, as the name implies, can change their values while the program runs. But quick warning, if you declare a variable without giving it an initial value, it's just going to hold unpredictable, dangerous garbage values from old memory. Constants, on the other hand, are fixed. Using the const keyword gives you essential safety for values, like pi, that should literally never, ever change. Section 4. Operators and Logic. This is where we get the computer doing the actual work. Let's start with a fun little trap. Quick pop quiz. What happens when you divide 5 by 2 in C? If you instinctively said 2.5, well, you've just hit another danger zone. In C, when both numbers are integers, integer division entirely truncates the decimal. It just chops it right off. So 5 divided by 2 equals exactly 2. No rounding. You actually have to cast one of those numbers to a float if you want that decimal back. Aside from just doing math, we also need logic. Logical operators let our programs test multiple conditions at once. The double ampersand means and. The double pipes mean or. And here's a really cool efficiency trick. C uses something called short-circuit evaluation. Basically, if the first condition in an and statement turns out to be false, C doesn't even bother checking the second one. It already knows the whole statement is false, so it just skips ahead to save time. Okay, focus in, because this is honestly the most classic beginner mistake in all of C programming. Two equal signs compare values to see if they're the same. A single equal sign assigns a value to a variable. If you accidentally type if x equals 5 with just one equal sign, you aren't checking if x is 5. You are forcefully shoving the number 5 into x, which makes the statement permanently true and totally wrecks your logic. Section 5, Input and Output. How our program talks to the user. The most crucial takeaway here is that without including the standard input/output header file, that's #include stdio.h at the top of your file, your program is completely deaf and mute. This one single line is what connects your code to the outside world, hooking up your keyboard for input and your screen for output. And the two heavy lifters provided by that header file are printf and scanf. Printf formats and pushes your output to the screen using those format specifiers we talked about, along with handy escape sequences like /n to drop to a new line. Scanf, meanwhile, does the listening. It reads formatted data straight from the user's keyboard. But be careful, because scanf comes with a massive danger zone of its own. You absolutely positively cannot forget the address of operator, that little ampersand symbol, when reading data into a standard variable. If you forget it, scanf literally has no idea where in memory your variable lives. It'll just send the user's input to a random garbage memory address, and yep, your program will instantly crash. And finally, Section 6, Control Structures. We're giving our program a brain. Control structures are basically the traffic cops of your code. They determine the exact flow of execution. Like we said earlier, without them, a program would just boringly execute straight from top to bottom exactly one time. These structures are what give your software actual flexibility, letting it react dynamically to whatever the user does. There are three main flavors you need to master. First is sequential, which is just your standard, default straight line execution. Second is selection. This creates branching decision paths, forks in the road, using if, else, or switch statements. And third is iteration, which lets you loop repetitive actions over and over using while or for loops. Combining these three, that's what makes a program truly intelligent. And that brings our whole architectural arc to a close. Think about how far we've come, from understanding how raw text compiles into machine code, to managing memory boxes, navigating logic, and setting up dynamic loops. You now understand the complete structural foundation of the C programming language. C hands you these incredibly powerful building blocks, but at the end of the day, it relies entirely on you to provide the human logic. So I'm going to leave you with this final thought. We've laid the foundation and we've walked through all the tools in the toolbox. But how are you going to use these building blocks to start writing your own recipes and solving real-world problems? The possibilities are quite literally endless. Thanks so much for joining me on this explainer, and hey, happy coding!